Hello class, Miss Emami here. Today we are going to have our last lesson for quadratic relations, and in this lesson we are going to continue with some word problems with quadratic models. In the first example that we are going to do, we have a quadratic model here about jump on a planet. The force of gravity on the moon is about 6 times weaker than that on Earth. The flight of a jumping astronaut can be modeled by this equation: h equals negative 0.8 d minus 2.5 squared plus 6. Now, h represents the height of the astronaut in meters, and d represents the flight or the horizontal distance in meters traveled astronaut. So you can think of it that if this is the astronaut, this is kind of a movement that every time the astronaut jumping, it's having this kind of a movement because it's quadratic, so it's going to be a parabola. This is the height in meters, and this is the distance in meters. And the equation we have is now, in your head, you can think of it as your h is your dependent variable, which you can think of it as how we thought about our y value, and then d is your independent variable, which is how would you think of your x and y coordinates. Now, the first question to answer here is, what was the astronaut's maximum height and when did it occur? Now, maximum height, you remember maximum in a parabola, that means we are talking about vertex. We are talking about vertex. So looking at this equation, vertex is, this is your h value, so opposite in sign, so it's 2.5 and 6. Now, one of them represents the independent variable, which is distance, and this one represents the dependent variable, which is height. Now, this is a word problem, so you have to and is the maximum height, so this is going to be 2.5 and this is going to be 6. So you are going to write the maximum height is 6 meters and it occurs at 2.5 meter from starting. So the astronaut has a very big jump, and 2.5 meter through the jump, it's going to reach the highest height and then it will come down. Now, the next question here is, what was the astronaut's initial height above the ground? So that means that this astronaut necessarily was not on the ground when it was jumping. Maybe there was a rock he was standing on or something like that. At this point, when we start this whole parabola, our d value at the beginning of this jump is 0. In order to find this, the only thing you have to do is you have to let the d value 0, because at a starting point, because initial height means at starting point. So you use the equation and you substitute 0 for d. So h equals negative 0.8, 0 minus 2.5 squared plus 6. Order of operation, you're going to do the bracket first. So negative 0.8. 0 minus 2.5 is negative 2.5 squared plus 6. You have to use the exponents next, BEDMAS. So negative 2.5 squared is 6.25. So h equals negative 0.8. times 6.25 plus 6, and then you are going to punch this in your calculator. So negative 0.8 times 6.25 plus 6, 1. Again, it is a word problem, so the initial height was 1 meters. And now here we have one more question that we want to answer, is that can the astronaut jump over a rock which is 4 meters high and 1.5 meters away from his or her starting point? So let's one more time do a sketch here just for us to see what we are talking about. So we have here at 1 meter, now we know that our astronaut will start jumping. And we know that at 2.5 meter it reaches 6 meter. And now there is a rock here. There is a rock at 1.5 meter. And this rock is 4 meters high. So here we have a rock. I'm going to use a different color. So here we have a rock. This is the rock at 1.5 meter. And we want to see, can the astronaut go over this rock, or the astronaut will actually hit the rock. Now we know that this rock is 4 meters. So the whole idea is, if we figured out what is the height of the astronaut at 1.5 meter, then we will know if it's more than 4 meters, the astronaut can go over this rock. If at this point the astronaut is lower than 4 meters, it will hit the rock. So what we need to do is we have to let d equals 1.5. So I'm going to write the equation again. and we are going to sub 1.5 for D. So H equals negative 0.8, 1.5 minus 2.5 squared plus 6. For some of you, if your calculator has the correct order of operation, you can do the whole thing in one go. Otherwise, you have to do with individually doing the order of operation. So for example, my calculator will allow me to do the whole thing in one go. So 1.5 minus 2.5 squared plus 6. H was 5.2 meters. So at this point, the astronaut is actually at here. The astronaut is at 5.2 meters, which is above 4 meters. So it's safe. The astronaut is almost 1.2 meters above the rock. So the question is, can the astronaut jump? Yes, the astronaut can jump because he or she is 1.2 meter above the rock. So as you can see, I just did a sketch for us to be able to conceptualize this more, but for these kinds of questions, you can even do the questions without doing a sketch of the parabola. Now, let's do one more example. A golf ball is hit from the top of a cliff and fell to the green located at the bottom of the valley. The path of the golf ball can be modeled by the parabola h equals negative 2.5 t minus 5 squared plus 170. So this is the equation. H is the height in meters above the valley, and the time after the ball was hit in second is given in t. So again, it doesn't hurt if you do some kind of a sketch here just to get an idea of what's happening. So we have a cliff and we have a golf ball and we have a putter, and I'm sure you know that art is not my forte. So this is going to be hit, it goes up and then it will come down. So, and this is the green. So this is the green. Now, what we have here involved is we have time here as our independent variable in seconds, and here we have the height as our dependent variable. So I'm going to write this here. H equals negative 2.5 t minus 5 squared plus 170. So the first question here is identify the coordinates of the vertex. So again, the vertex is here we have to use the number in opposite sign of the 5 and 170. So 5 and 170. 70. Now please remember that the first thing always represents your independent variable, which is time, and the second one represent, again, think about it as your y versus your x, and the second second coordinate represents your dependent variable, which is height. And the vertex is where we get to the maximum height. This at here we get to the maximum height, and after that the ball will go down. Now the question here is, what is the maximum height of the golf ball? So this number, this coordinate represents the height, and the y coordinate of the vertex represents the maximum. So the maximum height is 170 meters. How long does it take the golf ball to reach its maximum height? So as you can see here, at 5 seconds, this is happening at 5 seconds. So at 5 seconds, it reaches the maximum height. So we are going to write here, the ball reaches the maximum height after 5 seconds. Now, the next question is, what is the height of the ball after 3 seconds? So that means we know that t is 3 and we want to find h. So what we have to do is we have to substitute t equals 3 in the equation. So h equals negative 2.5, 3 minus 5 squared plus 170. Negative 2.5, 3 minus 5 squared plus 170. So h equals 160 meters. So I'm going to write the height is 160 meters after 3 seconds. And then the question asks for a similar kind of a concept, that what is the height of the ball after 7 seconds. So again, we have to do the same thing. Let t equals 7 after 7 seconds. So h equals negative 2.5, 7 minus 5 squared plus 170. So we are going to sub it in here. So negative 2.5, 7 minus 5 to the exponent 2 plus 170. And again, the answer is 160 meters. The height is 160 meters after 7 seconds. And then you may ask yourself, how is this possible? Like, what do we notice here? How come are both the same heights? So I'm going to do the sketch again here, and I think that will make it more clear to you what's happening here. So from over the cliff here, we are hitting the ball, and we know at 5 seconds it reaches the maximum height, which is 170. But then if you pay at 3 seconds and at 7 seconds, ball is at the same height, which happens to be 160 meter. So in one of them it is at 160 meter in its way up, going to the maximum height, and again when it comes down it reaches the same height of 160 and comes down. So two heights the same at 3 seconds and 7 seconds. One is in the way up, the other one is in the way down. One in the way up and one in the way down. So the other question is, what is the height of the cliff? Okay, the height of the cliff, we can recognize the height of the cliff when the time is 0. That's the height where the whole, so it's actually here, it's, if this is time, when time is 0, that tells you what's the height of the cliff. So in order to figure out, you have to let t equals 0 in the equation. So h equals negative 2.5, 0 minus 5 squared plus 170. And you can put this in one go if your calculator has the order of operation. So 0 minus 5 squared plus 170, 107.5. So the height of the cliff is 107.5 meters. And then the last question we want to answer here is, when is this golf ball going to hit the ground? So again, this is the time and this is the height. And this is the ball. This is where it hits the ground. Hits the ground means height is 0. So that means in our equation we are going to put 0 for t. So 0 equals negative 2 t minus 5, 170. Now again we are trying to isolate t, So the first thing we have to do is 170 has to move to the other side of the equal sign, so we have to subtract it. It goes to the other side and it becomes subtracted. So negative 2.5 t minus 5 squared. Now 0 minus 170 is negative 170 equals negative 2.5 t minus 5 squared. Now again we want to isolate this, so and this is being multiplied, so you have to divide both sides by negative 2.5. Negative 170 divided by negative 2.5 is 68. So 68 equals t minus 5 squared. Now opposite squaring is square root, so I take square root of both sides. Square root of 68 is 8.2. So I'm going to continue the work here. 8.2 equals t minus 5. And in order to isolate t, we're almost there. In order to isolate t, we have to move negative 5 to the other side, so we have to add 5 to both sides. So 8.2 plus 5 equals t. So t equals 13.5 seconds. So that means at 13.5 seconds the ball hits the ground. So the ball hits the ground after 13.5 seconds. So in these two lessons, we've looked at two kinds of word problems. The first kind is the kind that the scenario is given to you. You have to plot the graph and then from there write the equation and answer some questions. In today's lesson, we look at questions where the equation is actually given to you, and then based on the equation, you have to answer some questions. Although you're not required directly to plot the graph, it's always very helpful to have a sketch so you can understand what's happening in the question. Enjoy the rest of your day. Stay safe. Goodbye.